Welcome to my YouTube channel. In this video, we're looking at the chemical and the physical properties of ammonia. The chemical and the physical properties of ammonia. So we'll start with the chemical properties of ammonia. And here we'll be looking at five basic properties. Five basic properties that usually shows up in examination. So the first chemical property of ammonia that we're going to look at is reaction with oxygen. So when ammonia reacts with oxygen, this is ammonia. When it reacts with oxygen, it forms water and nitrogen. This is what the reaction of ammonia with oxygen entails. When ammonia reacts with oxygen, it forms water and nitrogen gas. But when ammonia reacts with excess oxygen, this is just reaction with oxygen. When ammonia reacts with excess oxygen, and it reacts with excess oxygen in the presence of a platinum catalyst. So when ammonia reacts with excess oxygen in the presence of a platinum catalyst, nitrogen 2 oxide and water is formed. So the first reaction is just reaction with oxygen, not excess oxygen, limited amount of oxygen. That will lead to the formation of water and nitrogen. But when ammonia reacts with excess oxygen in the presence of a platinum catalyst, nitrogen 2 oxide is formed. So just know the difference between the two reactions. When it reacts with oxygen, that is with limited amount of oxygen, nitrogen gas is formed. But when it reacts with excess oxygen, nitrogen 2 oxide is formed. And this reaction is catalyzed by platinum. To take us further, let's look at this 2009 JAM question. The oxidation of ammonia in excess air produces A. Nitrogen 2 oxide, B. Dinitrogen monoxide, C. Nitrogen 4 oxide, and D. Dinitrogen tetraoxide. So which of the following compounds or which of the following substances will be produced when ammonia is excessively oxidized? So from what we've discussed before, ammonia can react with excess oxygen. The reaction of ammonia with oxygen is an oxidation reaction. So ammonia reacts with excess oxygen in the presence of a platinum catalyst to yield nitrogen 2 oxide. And this is the chemical formula of nitrogen 2 oxide, NO. When it reacts with limited amount of oxygen without a catalyst, it will yield nitrogen gas. So the oxidation of ammonia in excess air, we're simply talking of the reaction of ammonia in excess air. And what will it produce? It will produce nitrogen 2 oxide. So our correct option to this 2009 JAM question is option A, nitrogen 2 oxide. So just a quick recap. We're looking at the chemical reaction or the chemical properties of ammonia. And the first chemical property we've looked at is the reaction with oxygen. When ammonia reacts with oxygen, this is ammonia. When it reacts with oxygen, it will produce water and nitrogen. That is in limited amount of oxygen. But when ammonia reacts with excess oxygen in the presence of a platinum catalyst, nitrogen 2 oxide and water is formed. So when it reacts with limited amount of oxygen, nitrogen is formed. When it reacts with excess of oxygen in the presence of a platinum catalyst, nitrogen 2 oxide is formed. So know the difference between the two reactions. So the next chemical property of ammonia we're going to look at is reaction with carbon 4 oxide. Reaction with carbon 4 oxide. So when ammonia reacts with carbon 4 oxide, very importantly, urea is formed. You must know this. When ammonia reacts with carbon 4 oxide, urea is formed. So this is ammonia reacting with carbon 4 oxide to form urea and water. And this is a very important organic product. It can be used as fertilizers, and even in the body, it is produced as a waste product of metabolism, and it is excreted out as urine. So this compound is very important, urea. So just know that when ammonia reacts with carbon dioxide, urea and water is formed. This is very important. Then the next reaction we have here is reaction of ammonia as a reducing agent. The reaction of ammonia as a reducing agent. So what is a reducing agent? A reducing agent is a substance, is any substance which either removes oxygen or adds hydrogen to a compound. So there are two basic things a reducing agent will do. It will either remove oxygen from a compound or add hydrogen to a compound. Removes oxygen from a compound or it will add hydrogen to a compound. So any substance which will either remove oxygen from that compound or add hydrogen, that compound is, or that agent is known as a reducing agent. So what we're trying to say here is that ammonia will act as a reducing agent. That means when ammonia reacts with some certain compounds, it will remove oxygen from them or it will add hydrogen to them. So let's look at two instances of the reducing property of ammonia. The first instance we're going to look at is reaction with copper 2 oxide. Reaction with copper 2 oxide. So this is copper 2 oxide, this is ammonia. When ammonia reacts with this copper 2 oxide, it will remove this oxygen from the copper 2 oxide to form copper. So that is why ammonia is a reducing agent. It has removed oxygen from this copper 2 oxide to form copper, water, and nitrogen. And remember what we said, that a reducing agent is any substance which either removes oxygen or adds hydrogen to a compound. So in this instance now, oxygen has been removed from this copper 2 oxide by ammonia. So when ammonia reacts with copper 2 oxide, it will reduce the copper 2 oxide to copper. It is reducing it because it is removing oxygen from it. Then the other instance that we have here is reaction with chlorine. So when ammonia reacts with chlorine, this is chlorine, this is ammonia. When ammonia reacts with chlorine, it will form hydrogen chloride and nitrogen. So if you look at this reaction vividly, clearly, you will know that ammonia has added hydrogen atom to this chlorine. It has added 6 hydrogen atoms to this chlorine to form hydrogen chloride. So we can say that the chlorine has been reduced by the ammonia to hydrogen chloride. And remember what we said before, that a reducing agent is any substance which either removes oxygen or adds hydrogen. So from this reaction, ammonia is adding hydrogen to this chlorine to form hydrogen chloride. So this is what the reaction of ammonia as a reducing agent entails. It either removes oxygen from a compound or adds hydrogen to a compound. So the very important thing that you should know here is that just know that ammonia is a reducing agent. It can act as a reducing agent. So the fourth chemical property that we're going to look at is the reaction of ammonia as a base. Reaction of ammonia as a base. So if ammonia acts as a base, it simply means that when ammonia reacts with acid, it will form a salt. That's the reaction of ammonia as a base. A base is any substance which neutralizes an acid to form salt. Any substance that will neutralize or that will react with an acid to form a salt, that substance is a base. A base is any substance which reacts or which neutralizes an acid to form salt. And ammonia is an example of a weak base, So when it reacts with acids, it will form salt. So we're looking at the reaction of ammonia as a base. That means when ammonia reacts with acid, it will form a salt because ammonia now is acting as a base. So when ammonia, NH3, reacts with hydrochloric acid, HCl, it will form ammonium chloride. This ammonium chloride is a salt. This is an acid. So, and this is acting now as a base. So when this base reacts with this acid, it will form a salt. Ammonia, this is ammonia. When it reacts with tetraoxorbisic acid, it will form ammonium tetraoxorbisic acid. So this is a salt, this is an acid, and this is a base. So this is what the reaction of ammonia as a base entails. When it reacts with acid, it will form salt. With hydrochloric acid, it will form ammonium chloride, which is a salt. With tetraoxorbisic acid, it will form ammonium tetraoxorbisic, which is also a salt. So the last reaction of ammonia we're going to look at here is the thermal decomposition of ammonia. The thermal decomposition of ammonia. So ammonia decomposes at a temperature above 500 degrees Celsius to yield nitrogen and hydrogen. Thermal simply means heat. Decomposition simply means to break down. So we are looking at the breakdown of ammonia using heat. When ammonia is heated to a certain degree of temperature, the ammonia will break down to form nitrogen and hydrogen. So ammonia decomposes or it breaks down at a temperature above 500 degrees Celsius. So when ammonia is heated above 500 degrees Celsius, it will break down to form nitrogen and hydrogen. So this is ammonia, NH3. So when ammonia is heated to a temperature above greater than 500 degrees Celsius, it will break down to form nitrogen, N2, and hydrogen, H2. This is a gas, this is a gas, and this is a gas. So this is what the thermal decomposition of ammonia is all about. So we would need to balance this equation. There is one nitrogen atom here, three hydrogen atom here, two nitrogen atom here, two hydrogen atom here. So we need to balance this equation because they are not balanced. There is two here, one here, two here, three here. So we need to balance this equation. So to balance this equation, here will be two to balance the two nitrogen. So two nitrogen here, two nitrogen has been balanced already. So there are 2 times 3 hydrogen here, which is 6 hydrogen, and we have only 2 hydrogen here. So to make it balance, we'll put 3 here to make it 3 times 2, which is 6. So 6 hydrogen, 6 hydrogen, 2 nitrogen, 2 nitrogen. So this equation is balanced. So the main important thing just to know here is that when ammonia is heated to a temperature above 500 degrees Celsius, it will break down to form nitrogen, and hydrogen. So in summary, we have looked at the chemical properties of ammonia. First, we looked at the reaction with oxygen, and there are two scenarios we looked at: when ammonia would react with oxygen in excess and when it will react with oxygen in a limited amount. So when it reacts with oxygen in a limited amount, it will form nitrogen gas. But when it reacts with oxygen in excess, it will form nitrogen 2 oxide. So this is very important. Then we also looked at the chemical property of ammonia as a reducing agent. And we said that ammonia will either remove oxygen, it will either remove oxygen O2 from a compound, or it will add hydrogen. So any reaction whereby ammonia removes oxygen from a compound or add hydrogen to a substance, that reaction is a reducing reaction. So, and the next one we looked at was reaction with carbon dioxide, and we said that when ammonia reacts with carbon dioxide, very importantly, a substance called urea is formed, and this is an organic product. Then we looked at the reaction of ammonia as a base, and I said that ammonia reacts as a base because when it reacts with acid, it will form a salt. So ammonia is acting as a base. Then we look at the thermal decomposition of ammonia, and this is the breakdown of ammonia when ammonia is heated above 500 degrees Celsius. And I said when ammonia is heated above 500 degrees Celsius, above this, it will break down to form nitrogen and hydrogen. So before we go into the physical properties of ammonia, let's look at this 2009 JAM question. The oxidation of ammonia in excess air produces The oxidation of ammonia in excess air produces A. Nitrogen 2 oxide, B. The nitrogen monoxide, C. Nitrogen 4 oxide, and D. Dinitrogen tetraoxide. So from what we've discussed before, from the chemical properties of ammonia, we said that ammonia reacts with oxygen in two scenarios. It can react with oxygen in limited amount, whereby when it reacts with oxygen, it will form water and nitrogen. But when it reacts with excess oxygen in the presence of a platinum catalyst, it will form nitrogen 2 oxide. So the oxidation of ammonia is simply the reaction of ammonia with oxygen in excess air. So that means ammonia is reacting with oxygen in excess. So when ammonia reacts with oxygen in excess, it will produce nitrogen 2 oxide with the chemical formula NO. So the oxidation of ammonia in excess air produces nitrogen 2 oxide. So option A is the correct answer to this 2009 JAM question. The next question I have here is a 1984 JAM question. And the question is, looking at this reaction, then after looking at it, in the reaction above, ammonia acts as, in the reaction above, so in this reaction, ammonia acts as, so if you look at this reaction very well, this is chlorine, this is ammonia. Then when this chlorine reacts with this ammonia, nitrogen is formed, then hydrogen chloride. So if you look at this reaction clearly, you can only see one thing, that ammonia has added hydrogen to this chlorine to form hydrogen chloride, because what has changed here is that hydrogen has left the nitrogen, it has left ammonia to come and meet chlorine to form hydrogen chloride. So in the reaction above, ammonia acts as, so ammonia acts, is it as a reducing agent? Yes, because a reducing agent is any substance which either removes oxygen from a compound or adds hydrogen to a compound or any substance. So any agent or any substance that will either remove oxygen or add hydrogen to a substance, that compound or that substance is known as a reducing agent. So if you look at this reaction, ammonia has added hydrogen to the chlorine to form hydrogen chloride. So in the reaction above, ammonia acts as a reducing agent. So is it an oxidizing agent? No. Is it an acid? No. Does it act as a catalyst? No. Does it act as a drying agent? No. So in the reaction above, ammonia acts as a reducing agent. So this is the correct answer to this question. It is acting as a reducing agent because it will add hydrogen to the chlorine. It is adding hydrogen to chlorine to form hydrogen chloride. So with this, we are done with the chemical properties of ammonia. In the next video, we'll continue with the physical properties of ammonia.